If you're watching this video, you've already completed the graphing quadratics investigation and lesson. So you know that when we're solving a quadratic, we're looking for where the parabola crosses the x-axis on the graph. Sometimes that's twice, sometimes once, and sometimes not at all. This unit kind of reminds me of our systems of linear equations unit because there are multiple different methods to be able to solve depending upon what type of quadratic we have in front of us. So graphing was a great way to start out the chapter visually. There are also 4 additional ways to solve quadratics, and they're listed up here. Square roots, we're going to cover that today. Factoring, which you guys already know how to do. I've been telling you that that's not going away. It's going to come back this week. We also have completing the square and the quadratic formula. So for today, we're focusing on square roots, and square roots typically work great when we're solving a quadratic equation with no x term, meaning the b of the quadratic equation is 0. So I have a few examples, a few try it on your own like we've been doing. And this note set is split up into 3 different parts. So we'll do some examples, we'll do a few try it on your own, and we'll go kind of back and forth jumping around. So our first example is the top one from the notes that's done out for you. It has written steps. And all of these today, I'm just solving for the variable. I'm going to kind of ignore that it's squared at all, and I'm going to isolate that x squared. So for this one, I'm going to go ahead and add 7 to both sides. I'm left with x squared equals 16. Now I know the inverse operation of something squared is the square root of it. So at this point, I need to say, well, I'm going to undo that square, and I also need to do it on the other side. I'm left with x equals the square root of 16. And remember, when I have a square root, I have a positive answer and a negative answer. And I know here that the square root of 16 is 4. So x is going to equal plus or minus 4. You can write that as 4 and negative 4 if you wanted to. This is just a simplified version of that. These mean the same thing. So this parabola, if I graphed it, would cross the x-axis at 4 and negative 4. I'm just going to jump to the next example now. This one, same thing, I'm isolating that m. So the first thing I'm going to do is divide by 9. And when I divide by 9 here, I'm left with, that's not going to be an integer. 9 does not fit into 169 evenly. What I do notice is that I have a perfect square in my numerator and a perfect square in my denominator. So when I get m alone, what I'm doing is finding the square root of that. And this I can just rewrite like this. Some of you guys like to see it like that better. The square root of 169 over the square root of 9. And I know that the square root of 169 is 13. And I know that the square root of 9 is 3. And I know when I find a square root, I have a positive and a negative answer. So here, if I were to graph that parabola, it's crossing at about positive 13 over 3 and negative 13 over 3. Now that one we could not have found an exact answer with if I graphed it. So solving with square roots was a good method for this one. The next one I have here, this is like a 2-step equation, but I have a squared variable. I'm going to start by subtracting 81 on both sides. I'm left with 16m squared equals 0. Now, no matter what I divide by, when I do 0 divided by anything, I'm just going to be left with a 0. So this quadratic is going to have one answer. The vertex of my parabola would be on the x-axis here because my x is equal to 0. I have one answer. It's not touching. The vertex is going to be just touching the x-axis there. And last example I have for you to do out is a special case one. And you guys will recognize this. When I subtract 13 on both sides, I'm left with z squared equals negative 8. Now, whenever I have a squared variable equal to a negative number, I cannot find the square root of a negative number. So we say no solution. Would be no solution. Now, if I graphed this parabola, it's not going to touch the x-axis. So that means that we're going to say no solution. So now I have 4 problems that I want you guys to try on your own. I'm going to pull it back, and you guys can pause it and write these down. If you have the notes, they're scattered about in that try it section. You can pause now, write it down, and I'm going to reveal the answers. So for the first one, I have plus or minus 1. The second one, plus or minus 3. The third one, plus or minus 2. And the last one was one of those that ends up in a fraction, plus or minus 11 over 6. And now we're going to move on to the next section. These type of problems happen when our roots or our solutions are not integers. So we're able to estimate decimal answers, or we can give actually a more accurate answer in radical form. So radicals are going to come back in this type of problem. I'm still isolating that variable, and then I'm just going to show my answer in a little bit different of a way because of what my answer is. So here, the first thing I would do is subtract 5 on both sides. And I'm left with 2x squared equals 10. Now after that, I'm going to divide by 2, just like I would with a normal two-step equation. And I'm left with x squared equals 5. Now I need to undo that squared, so I'm going to do the square root of it. And what you notice here is this is not a perfect square. The 5 is not a perfect square. So I'm left with x equals plus or minus the square root of 5. And depending upon what the directions ask you to do, this is actually simplified radical form. You would be done here. The directions for the try it section say to round it to the nearest hundredth and simplified radical form. So this actually you are done with for simplified radical form, but it asks us to give our answer in 2 different ways. So plus or minus 5, and I can leave this answer as is because I cannot break down the square root of 5 anymore. It's a simplified radical. Now, if I went and figured out decimal form, when I type in the square root of 5, I'm going to have a positive and a negative answer again. And it's going to be 2.24. Make sure you round correctly when you do that. When you type it in your calculator, look what the directions are asking for. Here it's asking for hundredths, so make sure you round correctly. I have one more example of this type, and I picked this one specifically. This one's, if you have the notes printed out in front of you, it's the bottom right, try it. And I'm going to solve as normal. I'm adding 50 to both sides. I'm left with x squared equals 50. And we all know that 50 is not a perfect square. 49 is a perfect square, and 50 is right near it, so we could estimate that. We can also break it down and give it in simplified radical form. So I know that if x squared equals 50, x is equal to plus or minus the square root of 50. Now I'm just kind of going to let that hang out there. If I need to give simplified radical form, I did not need to do anything over here because the square root of 5 is already simplified. I can't break that down anymore in a factor tree. It's prime. So over here, I actually can break this down. I know that 50 can break into 5 and 10. 5 is prime, I circle. 10 can break down to 5 and 2. Now, if you remember back to the radical unit, I know when I have a pair, that can come outside. And if I don't have a pair, it stays inside. So 5 root 2 is what I have here. So this is actually going to be simplified radical form, the positive and negative version of that. So I had an extra step on it. We needed to simplify that radical. Now for decimal form, you're going to type in plus or minus 5 square root of 2. So you can type in a positive 5 times the square root of 2, and then separately type in a negative 5 times the square root of 2. And when you type that in your calculator, you should end up with plus or minus 7.07. And now sometimes I'll recommend that you actually don't use your simplified radical form when you're trying to get decimal form. If you just typed in your calculator square root of 50 and then negative times the square root of 50, you'll end up with the same thing and maybe prevent a mistake from happening. It's a little bit easier to type it in your calculator that way. Now think back to our radical unit. This answer makes sense because we know the square root of 49 is 7, so the square root of 50 has to be a little bit more than that. I have one more type of equation that we're going to solve with square roots today. And this is written in a form that allows you to use square roots even though there would be an x term if I factored this out. If I multiply that out, there would be an x term. However, given in this form, I'm able to solve it, find the square root, and have my answers. So for this one, the first thing I'm going to do is I'm going to think of this whole x plus 3, that whole binomial in there. I'm going to think of that just as like one variable, and I'm going to isolate that. So I need to get rid of this 3, and I have 3 times what's in the parentheses there. So in order to get rid of it, I'm going to divide, dividing by 3 on both sides, and I'm left with x plus 3 squared is equal to 13. Now the next thing I have to do is get rid of this squared. That whole binomial is squared, so I can go ahead and square root the entire thing to cancel out that 2, that squared number. And if I do it on one side, I'm doing it on the other side. So what I'm left with here is x plus 3 is equal to plus or minus, don't forget that, plus or minus the square root of 13. Now my x is not isolated yet, so I have plus 3 next to it. I need to subtract 3 to get rid of that. Now I'm going to write the integer out front. I'm going to say negative 3 plus or minus the square root of 13. And that's actually in simplified radical form. I can't break down the square root of 13 anymore. I can't combine them. I'm just going to say negative 3 plus or minus the square root of 13. Now, if this were me doing this on my calculator, I would figure out what the square root of 13 is to go from radical form to decimal form. A lot of you are using your cell phone calculators, so I've played around with it a bit, and I've determined the easiest and most accurate way to do this would be to figure out what the square root of 13 is. Now, I already know, I did it ahead of time, I know the square root of 13 is about 3.61. And again, I'm rounding to the hundredths place because the directions tell me to do so, and I'm being careful to round accurately. So the square root of 13 is equal to about 3.61. Now when I'm going from radical form to decimal form, I'm going to do negative 3 plus 3.61, and I'm going to do negative 3 minus 3.61. Now when I do that, I end up with 0.61, and I end up with negative 6.61. And that would be done. I'm going to do one more type, and I'm choosing this one because I am going to be able to simplify the radical. So this one looks, at first glance, it looks just like the one that we just did, and it is. We're going to go about it in the same way. I need to isolate this x minus 1 first, so I'm going to divide by 5. So I have x minus 1 squared is equal to 8. And now I need to undo that squared. So I'm going to do the square root of it. And I'm left with x minus 1 is equal to plus or minus the square root of 8. Now I need to isolate that variable. If I have a minus 1, I'm going to add 1. And I'm going to write the integer out front. So I'm left with x is equal to 1 plus or minus the square root of 8. Now in the previous example, when I had the square root of 13, I was just done with radical form. However, here, this one is a little bit more involved because the square root of 8 is not simplified. I am able to break that down more. I can break it into 4 and 2. 2 is prime. 4 can come to 2 and 2. And I'm going to pull out in pairs. A 2 can come out, and I've got a 2 left inside. So instead of writing the square root of 8, I'm going to write 2 root 2 because that's simplified. So when I'm writing simplified radical form, I'm going to say 1 plus or minus 2 root 2. And again, to change into decimal form, maybe stay away from the simplified and go back to the square root of 8 since they have the same value. You can figure out what is the square root of 8. So I know that 2 root 2, or the square root of 8, is equal to about 2.83. And remember to be careful with your rounding. So it's about 2.83. Now in my calculator, I'm going to type 1 plus 2.83, and I'm going to do 1 minus 2.83. Now when you do that, you are left with 3.83 and negative 1.83. And you would be done with that. You have your radical form and your decimal form. So I'm going to go back and have you guys try some from the second section. I'm realizing I skipped that try it section when we did, when it wasn't an integer. So I'm going to have you guys try those two now. This is back to the second section of try it. Write those down, or you can start them on your notes. Pause the video so you can try it, because I'm going to show you the answers now. Back away. So for that top one, in simplified radical form, I have plus or minus root 3. And when you change it into decimal form, you should get plus or minus 1.73. And for the second example, radical form, you should get plus or minus root 5. And for decimal form, you should get plus or minus 2.24. And then we have the try-its from the third section. The try-its from the third section look like this. You can pause your video, write them down, try it on some scrap paper. If you have the notes printed out, try it right there. Pause your video because I'm going to show you the answers. And that first one is a little bit different than one that we did as an example. These numbers come out to integers, so even though it asks me to write it in radical form and decimal form, that is not necessary here. We can just simplify it out completely, and we're going to write negative 1 and negative 7. For the bottom one, I'm left with 5 plus or minus root 3 over 2. And when I change that into decimal form, I get 5.87 and 4.13. Now for all these tried examples, if you did not get what I got, I didn't show all my work out on these ones, but I did post my notes completed. So you're able to get those under today's assignment. So you can go check out my work and look for your mistakes if you didn't get them.